In the early years of the 20th century, in the quiet neighborhoods of Far Rockaway, New York, a young boy was discovering the universe in the most unexpected places. Inside broken radios, within the patterns of light, and in the rhythm of questions that never stopped flowing. His name was Richard Feynman. Long before he became one of the most brilliant physicists of the modern age, he was just a curious child with an insatiable hunger to understand how things worked. Curiosity was not merely a trait for him, it was the very language through which he spoke to the world. Every screw, every wire, every spark was a mystery calling out to be solved. His father, Melville Feynman, was not a scientist, but had a mind that loved knowledge. He often told young Richard stories about nature, about the stars, the wind, and the invisible forces that govern the world. But he did not just tell stories, he taught Richard how to think. He would say, "You can know the name of a bird in all the languages of the world, but when you're finished, you'll know absolutely nothing whatever about the bird. You'll only know what humans call it. So let's look at the bird and see what it's doing. That's what counts." Those words would stay with Richard forever. They were not lessons in science, they were lessons in perception, in the art of seeing beyond names into the truth beneath. In his small bedroom, surrounded by tools and scraps of metal, Richard began experimenting on his own. Radios fascinated him. The magic of sound traveling through invisible airwaves felt like a hidden universe waiting to be uncovered. When other children played outside, Richard was inside, taking apart devices and putting them back together, guided not by manuals but by sheer intuition. He learned how electricity flowed, how circuits responded, and how sound was born from invisible oscillations. His neighbors would often bring him broken radios, and the boy would sit with a screwdriver in hand, listening not to the noise of the radio, but to the logic inside it. He could tell where the problem was just by the tone it made. Soon, the community knew him as the kid who fixes radios by thinking. What made Feynman's early brilliance unique was not just his intelligence, but the way he played with knowledge. For him, learning was never about memorizing facts, it was about understanding deeply, seeing connections between things others ignored. He built his own laboratory in his home, complete with wires, batteries, light bulbs, and gadgets. He would perform little experiments, not because someone told him to, but because he needed to satisfy his curiosity. He loved to test the boundaries of what was known, and what could be discovered with imagination alone. There was a kind of purity in his curiosity, a childlike wonder that never faded. While most children grow out of that endless questioning, Richard's curiosity only expanded as he grew. He asked questions about everything. Why do objects fall? Why do things heat up? Why does light bend? And if it bends, could we make it do something new? Each question led to another, forming a chain of thought that would one day lead him to the heart of quantum mechanics. At school, Richard's teachers often underestimated him. He was bright, yes, but he didn't always follow the rules. He questioned everything they said, not out of arrogance, but because he genuinely wanted to know why something was true. When they taught formulas, he wanted to understand where they came from. When they recited laws of nature, he wanted to test them himself. He wasn't interested in answers given by authority, he wanted the proof that came from experience. This trait, which often irritated teachers, was the foundation of his scientific genius. For Feynman, science was not about believing, it was about finding out. As he entered his teenage years, Richard's experiments became more ambitious. He built alarms, electric motors, and even his own crude measuring devices. Mathematics fascinated him deeply, it became his second language. He would spend long hours solving problems, deriving equations from scratch, exploring how numbers could describe the world. He discovered early on that mathematics was not just a tool. It was a kind of poetry that allowed him to communicate with the universe itself. Equations weren't dry symbols to him, they were alive, filled with meaning and rhythm. When he attended Far Rockaway High School, Feynman's brilliance began to stand out unmistakably. He devoured every science book he could find and often went beyond the syllabus, exploring advanced concepts on his own. His notebooks were filled with personal derivations, playful calculations, and doodles of ideas that others might have dismissed as nonsense. But within those scribbles lay the seeds of the creativity that would later revolutionize physics. Teachers began to recognize that he wasn't just a good student, he was something else entirely, someone who saw the world through a different lens. Yet, for all his brilliance, Richard never saw science as something serious or heavy. To him, it was a game, a grand cosmic puzzle meant to be enjoyed. He once said, "Physics is like sex, sure, it may give some practical results, but that's not why we do it." Behind the humor was a profound truth. Feynman believed that the joy of discovery was its own reward. This joy, this playfulness, was something he inherited from his father's way of teaching. The idea that learning is not about collecting facts, but about delighting in the mysteries of nature. The household in which Feynman grew up was not wealthy, but it was rich with curiosity. His mother, Lucille, had a strong sense of humor and a sharp wit, and she encouraged his sense of play and imagination. The dinner table was a place of laughter and learning, where science mixed with jokes, and curiosity was never dismissed. His parents didn't pressure him to succeed, they nurtured his questions. This freedom to explore, without fear of being wrong, shaped Feynman's fearless approach to thinking, a quality that would define his scientific career. Even as a child, Feynman began to develop a unique sense of logic, a kind of intuitive mathematics that went beyond the classroom. He found shortcuts to solve problems, discovered patterns no one pointed out, and often came up with solutions his teachers hadn't seen before. He would solve problems his own way, and then compare the answers, often finding his methods simpler and more elegant. This habit of creating his own path would later become his signature in the scientific world. There's a story from his youth that captures his spirit perfectly. One day, when he was about 11, he was playing with his friend in the backyard. They noticed a ball rolling inside a wagon and wondered why it moved back and forth as the wagon stopped and started. While most children might have just laughed and moved on, Feynman began to think deeply about what was happening. He didn't have the words yet, inertia, momentum, or Newton's laws, but he had the instinct to question. Years later, he would recall that moment as the first time he started to think like a physicist, to notice small things and ask what they meant about the laws of the universe. As he matured, that curiosity became a kind of compass, guiding every decision he made. When something didn't make sense, he couldn't rest until he figured it out. He described his process as playing with ideas, and that's exactly what it was. He would tinker, test, imagine, and reshape thoughts like clay until they revealed something beautiful. He once said, "I learned very early the difference between knowing the name of something and knowing something." That distinction, between words and understanding, became the essence of his life's philosophy. When he reached college age, Feynman's curiosity had already made him a local legend among friends and teachers. He was accepted to the Massachusetts Institute of Technology's MIT, one of the most prestigious universities in America. There, his appetite for knowledge only grew. He dove into every subject he could find, mathematics, chemistry, engineering, but it was physics that captured his soul. To him, it was the perfect marriage of curiosity and logic, imagination and precision. He spent endless nights in his dorm, scribbling equations on scraps of paper, exploring how the invisible forces of nature connected everything in the universe. Feynman didn't just study physics, he played with it. He would invent imaginary scenarios. What if we could see electrons dance? What if light had a personality? And then try to calculate what would happen. This habit of playful thinking became one of his most powerful intellectual tools. While others approached physics with strict seriousness, Feynman treated it like jazz, improvisational, free, and full of rhythm. In these early years, His brilliance was evident not just in what he knew, but in how he thought. He refused to be limited by convention. If a problem seemed too difficult, he would find a new angle to approach it. If a theory was too abstract, he would try to visualize it until it became simple. He believed that nature could always be understood if one asked the right questions in the right way. It wasn't about memorizing what others discovered, it was about rediscovering it for yourself. Looking back, it's clear that Feynman's early life was not defined by privilege or access to the world's best laboratories. What set him apart was his relentless drive to explore. His mind was like a laboratory that never closed. He didn't need expensive tools. His greatest instrument was his curiosity. That same curiosity would one day lead him to challenge Einstein's ideas, reshape quantum theory, and inspire millions to see the beauty of science. Richard Feynman's childhood and youth were a living proof that genius is not born from knowing everything. It's born from never stopping the search to understand. His early brilliance was not a product of talent alone, but of passion, persistence, and an unshakable belief that the universe could be known through play, wonder, and a fearless sense of curiosity, even as the world around him grew darker. Through the years of war and uncertainty, that light of curiosity never dimmed. In The Boy Who Fixed Radios by Thinking, who questioned why a ball rolled inside a wagon, and who laughed while solving equations late into the night, there was the seed of a man who would one day make the quantum world accessible to everyone. Feynman's early years remind us that science begins not in laboratories, but in the simple act of asking why. As Richard stepped into adulthood, the world around him began to expand just as quickly as his imagination. The boy who once tinkered with radios had now entered the grand halls of learning, where the mysteries of the cosmos waited to be explored with real instruments, equations, and ideas. Yet even in these hallowed places of intellect, Feynman remained utterly himself, curious, mischievous, and endlessly questioning. When he arrived at the Massachusetts Institute of Technology, he carried with him not the stiffness of a scholar, but the sparkle of a boy still eager to play with nature. MIT in those days was alive with ambition. The air was thick with the sounds of chalk against blackboards, the hum of early laboratories, and the restless energy of minds trying to rebuild a world shaped by science. For Feynman, it was paradise. He immersed himself in the study of physics with a passion that astonished his professors. Yet he never took knowledge as something sacred or unreachable. To him, every formula was a challenge, not to be memorized, but to be re-understood in his own way. If he didn't like how a textbook explained something, he simply derived it himself from the beginning. He developed a reputation among classmates for his wild enthusiasm and his ability to make even the most difficult problems look like a puzzle game. When others struggled with abstract mathematics, Feynman would grin, tap his pencil against the desk, and say, "Let's see what happens if we look at it differently." He wasn't satisfied with learning from authority. He trusted his instincts, his logic, and above all, his curiosity. He once described his approach simply, "What I cannot create, I do not understand." For him, understanding meant rebuilding the truth from scratch until it became crystal clear. During his years at MIT, Feynman also developed his signature humor, the kind of wit that could dissolve fear in the face of complexity. He often entertained his peers with quick jokes during problem-solving sessions, turning tense moments of confusion into laughter. But behind the humor was a serious lesson: learning should never be a burden. It should be filled with joy, wonder, and even silliness. He would later say that the best way to keep curiosity alive is to keep a sense of play, and that idea, perhaps more than any equation, became his personal law of physics. Outside his classes, Richard continued to explore on his own. He would wander through labs late at night, examining instruments, watching experiments, and sketching the ideas that came to him. He learned to see beauty not only in results but in the process itself, in the delicate balance of trial and error, in the dance between failure and discovery. To him, Mistakes were not signs of weakness, they were invitations to learn. He treated every wrong answer like a friend pointing him toward something deeper. Feynman's relationship with mathematics also evolved during these years. Numbers became his companions, lines on a page his playground. He began to develop a new sense of intuition, one that allowed him to feel equations rather than merely compute them. He could visualize how quantities moved, how forces balanced, how energy transformed. Later in life, when asked how he solved difficult problems, he would smile and say, "I just look at the thing." What he meant was that his mind had trained itself to see the invisible. He could picture the hidden mechanics of nature as vividly as most people see the color of the sky. It was around this time that his fascination with the smallest things, electrons, photons, atoms, began to take form. He wanted to understand not just how they behaved, but why they behaved that way. Classical physics could not answer his growing questions. The universe of Newton was too neat, too predictable. The world Feynman saw in his mind was buzzing, jittering, unpredictable, yet full of patterns. He began reading about the new field that had already started to shake the foundations of science: quantum mechanics. For the first time, he felt that he had found a home for his curiosity, a realm where the imagination could roam free and still obey the laws of logic. Even as he dived deeper into the mysteries of the subatomic world, Feynman never lost his connection to everyday reality. He could explain the dance of electrons with the same passion he used to describe the swing of a pendulum or the shimmer of sunlight on a puddle. To him, everything was connected, from the buzzing of bees to the vibration of light. He would often sit quietly, observing the ordinary world, and in those moments of silence, he found the language of physics written everywhere. By the time he graduated from MIT, Richard's name had already begun to circulate among professors as someone to watch. A young man with an unconventional mind, a fearless thinker who would rather rebuild the foundations of knowledge than accept them as given. He decided to continue his studies at Princeton University, one of the most respected centers of physics in the world. There, he would find himself surrounded by giants, men like John Archibald Wheeler and Albert Einstein, yet even among them, Feynman's spark was unmistakable. At Princeton, his natural curiosity reached new heights. He wasn't intimidated by the great minds around him. If anything, he was inspired to push further. Wheeler, his advisor, recognized something rare in him, not just intelligence, but originality. Feynman's ideas were fresh, daring, and often a little outrageous. He was willing to question even the most sacred principles if they didn't make sense to him. That courage to doubt, born from his childhood habit of asking, why, now became the fuel for his genius. One story from Princeton captures the essence of his early brilliance. During a problem session, a senior professor presented an equation that everyone accepted as correct. Feynman raised his hand and said, "Wait, that doesn't make sense physically." The room fell silent. Rather than being embarrassed, he went to the board and derived the result from the beginning. By the end, he had shown that the accepted answer was incomplete. His version explained the behavior of particles in a more accurate and elegant way. The professor didn't scold him, he smiled and said, "Mr. Feynman, you have something special." It was moments like these that began to reveal the scale of his talent. But even as he moved closer to the center of scientific achievement, Feynman never lost his human side. He loved drumming, sketching, and joking with friends. He would play the bongos late into the night, tapping out rhythms that seemed to echo the patterns of the universe he studied by day. These rhythms, like his ideas, flowed freely, unbound by rules. He once said that the beauty of both music and science lies in improvisation, in finding harmony within chaos. This idea of playful order would later define his vision of the quantum world. During these years, he met Arline Greenbaum, a young woman whose warmth and humor matched his own. They fell deeply in love, but Arline was soon diagnosed with tuberculosis, a disease that carried a shadow of tragedy. Where many might have withdrawn, Richard's affection only deepened. He married her despite her illness, determined to share whatever time they could. In her laughter and courage, he found a different kind of wisdom, the understanding that curiosity alone isn't enough, life must also be lived with love and joy. The tenderness of their bond shaped his emotional depth and would remain with him long after she was gone. As World War II erupted, the world of science was drawn into a new and darker purpose. Feynman, still in his 20s, was recruited to work on the Manhattan Project, the secret effort to build the atomic bomb. It was here that his curiosity took on an unexpected weight. Surrounded by the greatest minds of the age, Oppenheimer, Fermi, Teller, Feynman brought not only his technical brilliance but his characteristic enthusiasm. He organized calculations, improved efficiency, and solved mathematical puzzles that baffled others. Yet deep inside, he felt the moral unease of a man who loved knowledge but hated destruction. Even amid the tension of wartime, his playful curiosity did not disappear. He became famous at Los Alamos for his pranks, opening safes, cracking codes, and finding joy in small acts of rebellion. But beneath the humor was a restless mind, struggling to reconcile the beauty of science with the harsh reality of war. When the bombs were finally dropped, Feynman's laughter fell silent. The same curiosity that had once been his light now forced him to confront the shadow it could cast. He later described standing in the desert, watching the test explosion, and feeling that something in the human spirit had changed forever. After the war, he returned to academic life, carrying both the brilliance and the scars of what he had seen. But his natural curiosity remained untouched. In fact, it seemed to burn brighter, as if he wanted to use his gift for something purer, for understanding rather than destruction. He began teaching at Cornell, and later at Caltech, where he would become legendary for his lectures. Students who walked into his classes expecting dry formulas found themselves swept into stories of wonder. He could turn a chalkboard into a stage, an equation into poetry. His curiosity became contagious. He made others want to see the world as he did, alive with mystery, full of patterns, and infinitely knowable. When Feynman spoke about science, it was never just about knowledge. It was about the joy of not knowing, the thrill of asking questions, and the humility of admitting that some answers remain hidden. He told his students, "I can live with doubt and uncertainty and not knowing. I think it's much more interesting to live not knowing than to have answers which might be wrong." This attitude, rooted in the same childhood curiosity that once led him to take apart radios, became a philosophy of life. As years passed, his curiosity evolved from a personal passion into a guiding light for others. He wanted everyone, not just scientists, to feel what he felt when he looked at the stars or when he saw a drop of water shimmering in sunlight. He could see the atomic dance within that drop, the endless motion of particles guided by invisible laws. To him, this understanding didn't take away the beauty of nature, it deepened it. He would say, "I have a friend who's an artist, and he sometimes takes a view I don't agree with. He'll hold up a flower and say, 'Look how beautiful it is,' and I'll agree. But then he says, 'I, as an artist, can see how beautiful it is. But you, as a scientist, take it apart and it becomes dull.' I think he's crazy. I can see the beauty of the flower at the same time as I see the molecules inside it." That was Feynman's gift. To find poetry in precision and wonder in reason. Even near the end of his life, when illness began to weaken his body, his curiosity never slowed. In hospital rooms, he still asked doctors how machines worked, how drugs interacted, why cells behaved the way they did. He drew diagrams on napkins, scribbled notes on envelopes, and continued to teach through stories and laughter. He refused to see death as an end, only as another mystery to explore when the time came. When Richard Feynman passed away in 1988, the world lost more than a scientist. It lost a voice that taught generations how to see. From the boy who fixed radios by thinking to the man who decoded the laws of quantum reality, his journey was defined by one simple, unstoppable force: curiosity. It was the same curiosity that led him to question, to imagine, to create, and to share. Today, his story stands as a reminder that brilliance is not measured by how much one knows, but by how deeply one wants to know. Feynman's early years, filled with tinkering, laughter, and wonder, built the foundation for everything he became. They taught him, and through him the world, that science is not a cold pursuit of facts, but a passionate dance with the unknown. In the echoes of his laughter, in the elegance of his diagrams, and in the simplicity of his explanations, the spirit of that curious boy from far Rockaway still lives on, reminding us that to truly understand the universe, we must never stop asking why. In the quiet aftermath of World War II, when the world was trying to heal and rebuild, a new kind of revolution was beginning, not on battlefields or in governments, but deep within the invisible world of light and matter. The stage was the atom, the players were particles, and the language was mathematics. Among those who stood at the edge of this unseen frontier was a young physicist whose imagination seemed to have no boundaries, Richard Feynman. The boy who once fixed radios by thinking had now stepped into the heart of one of science's greatest puzzles: how light and matter truly interact. For decades, physicists had tried to understand the strange relationship between electricity, magnetism, and light. The great James Clerk Maxwell had shown that light was an electromagnetic wave, a brilliant unification of forces that explained so much, yet not everything. At the atomic level, things did not behave so smoothly. Light sometimes acted like a wave, spreading in gentle ripples through space. At other times, it behaved like a particle, sharp, discrete, unpredictable. This dual nature confused even the most brilliant minds. The laws of classical physics, so elegant and consistent in the macroscopic world, began to crumble under the weight of quantum phenomena. The problem grew deeper when scientists tried to calculate how charged particles, like electrons, interact with light, or photons. The equations exploded into infinities, mathematical nonsense that made no physical sense. Every time physicists tried to apply quantum theory to electromagnetism, they found themselves lost in a forest of impossible numbers. It was as if nature had hidden her secrets behind a wall of paradoxes, daring humanity to look closer. It was into this chaos that Richard Feynman stepped, with the same fearless curiosity that had guided him since childhood. He was not intimidated by the infinities, he was fascinated by them. He believed that behind the confusion there must be a simple truth, something elegant and beautiful that humanity had not yet seen. Where others saw failure, he saw an opportunity to play, to explore the puzzle as if it were a game waiting to be solved. At Princeton, where he continued his graduate studies under John Archibald Wheeler, Feynman began shaping the foundations of what would later become his masterpiece, quantum electrodynamics, or QED for short. He approached the problem not as a mathematician trapped in formulas, but as a thinker seeking patterns. He wanted to visualize how particles behaved, not just compute them. His mind worked like an artist's brush, painting scenes of electrons and photons colliding, dancing, and transforming in the strange rhythm of the quantum world. Feynman's insight came from a radical idea, that instead of thinking of particles moving along a single path, we should imagine them taking every possible path simultaneously. An electron going from one point to another, he reasoned, doesn't just follow one route, it explores all possible routes, zigzagging, curving, even looping through space and time, and each of these paths contributes to the final outcome. The universe, in his view, was not deterministic but a grand orchestra of possibilities, where every path played a note in the symphony of reality. This way of thinking led him to invent a new mathematical tool called the path integral formulation of quantum mechanics. It was unlike anything the scientific world had seen before. Instead of describing particles with rigid equations, Feynman's method summed over all possible histories, each weighted by how likely it was to occur. It was an act of genius, a bridge between mathematics and imagination. He wasn't just solving a problem, he was reinventing the language of physics itself. But this was only the beginning. The true challenge was to combine quantum theory with electromagnetism, to describe, in a single framework, how light interacts with matter. This was the core of quantum electrodynamics. Earlier attempts had collapsed into infinities, giving answers like, the electron's energy is infinite, a clear sign that something was wrong. Feynman, along with two other brilliant physicists, Julian Schwinger and Sin Etero Tamanaga, approached the problem from different directions. Each found a way to tame those infinities using a technique called renormalization. It was a mathematical trick, but one that made physical sense. By carefully redefining certain quantities, the infinite parts could be cancelled out, leaving behind finite, measurable results. For most scientists, renormalization felt like sweeping dust under the rug, but Feynman saw beauty in it, not as a cheat, but as a clue that nature itself might work this way. He once said, with his characteristic grin, "You can't sweep infinities under the rug unless the rug is infinite." It was his way of saying that mathematics, when guided by intuition, could still reveal truth from chaos. To make his ideas clearer, Feynman began to visualize the invisible. He wanted a way to see how particles interacted, not in equations but in pictures, and so he drew. On scraps of paper, blackboards, and even napkins, he sketched little diagrams, arrows representing electrons, wavy lines for photons, intersections showing where they met or scattered. These simple drawings captured the essence of incredibly complex mathematical expressions. A single Feynman diagram could describe what might have taken pages of equations before. This visual language revolutionized physics. It allowed scientists to calculate the probabilities of interactions, of photons being emitted, absorbed, or scattered, with unprecedented accuracy. Suddenly, what had once seemed chaotic became clear and calculable. The diagrams became not only tools but a universal language of particle physics. Today, no physicist can work in quantum field theory without them. They are, in a sense, the hieroglyphs of the quantum world, a living monument to Feynman's genius. But Feynman's real triumph was not just in simplifying the math, it was in changing the way scientists thought. He taught the world to see physics not as rigid equations, but as stories of interaction, exchange, and motion. In his mind, the universe was alive, playful, and profoundly simple once you learned to look at it correctly. His diagrams didn't just represent physics, they were physics, translated into the human imagination. The accuracy of quantum electrodynamics was breathtaking. It could predict the behavior of light and matter with a precision that bordered on the miraculous. Experiments confirmed its predictions to an accuracy of 1 part in a billion, the most accurate theory in the history of science. To this day, no other framework matches it. Through QED, humanity had found a way to describe how the universe truly communicates at its smallest scales. Through the exchange of photons, the quanta of light. For Feynman, this was more than mathematics, it was music. He saw beauty in how the universe played with itself, exchanging energy, creating patterns, and revealing deep symmetries. He once described it as the strange theory of light and matter, but to him, it wasn't strange, it was pure, inevitable truth. What others found mysterious, he found natural. It was as if he had learned to speak nature's private language. Yet Feynman's genius lay not only in his discoveries, but in his ability to make them accessible. While other scientists wrapped their theories in formality, he spoke of them as if explaining a game. When a photon meets an electron, he would say, they dance. Sometimes the photon disappears, sometimes it comes back, and what we calculate is the chance of each kind of dance. That was the heart of his teaching, turning complexity into clarity, and clarity into wonder. As Feynman developed QED, his methods drew attention from physicists all over the world. Many were skeptical at first. His diagrams seemed too simple to represent the deep complexity of the quantum world. But as they tested his approach, they realized its power. Feynman's tools worked, and not just approximately, but perfectly. His strange little arrows and loops could predict the outcomes of experiments that even the most advanced mathematics struggled to describe. In 1948, at a famous conference in Shelter Island, Feynman presented his ideas to a room filled with the greatest minds of the era. He explained his theory not through dense derivations, but through intuition, logic, and humor. He walked the audience through the dance of particles, showing how every interaction could be imagined as a sum of possibilities. When he finished, there was a silence, the kind of silence that comes not from confusion, but from awe. His peers knew they had witnessed something historic. The old chaos of quantum electrodynamics had finally been transformed into harmony. It took years for the world to fully appreciate what he had done, but when they did, the recognition was monumental. In 1965, Richard Feynman shared the Nobel Prize in Physics with Schwinger and Tamanaga for their independent contributions to QED. For Feynman, the award was less about prestige and more about the joy of knowing that his playful curiosity had uncovered one of nature's deepest secrets. He laughed when he received it, joking that he'd rather be in his lab than at the ceremony. But behind that humor was quiet pride. Not in fame, but in understanding. Quantum electrodynamics was not just a scientific theory, it was a new way of seeing the universe. It united light, matter, and force in a single framework, showing that the universe is built not from rigid laws but from probabilities, from endless possibilities that weave together to create reality. Feynman's vision helped reveal that at the heart of existence lies a kind of cosmic play, unpredictable, dynamic, and endlessly creative. Even decades later, QED remains one of the cornerstones of modern physics. Every laser, every semiconductor, every digital device that uses light and electrons owes its existence to the principles Feynman helped clarify. But perhaps his greatest contribution was philosophical. He showed that the world, no matter how strange or abstract, can always be made understandable, that complexity is only a curtain hiding simplicity beneath. He proved that the universe is not built to confuse us, but to inspire us to look closer. Through QED, Feynman revealed the delicate heartbeat of creation, the endless exchange between energy and matter, the flickering conversations of particles that give rise to everything we see and touch. And in doing so, he gave humanity not only a theory but a vision, a way of seeing the world as it truly is, alive, shimmering, and full of mystery. As the echoes of applause from his Nobel recognition slowly faded, Richard Feynman found himself at an interesting crossroads. Many scientists, after such triumphs, retreat into quiet authority, satisfied to have left their mark. But Feynman was different. For him, discovery was never a destination, it was a way of life. The equations of quantum electrodynamics were not an ending, but an opening, a door to deeper questions about reality, perception, and the fragile boundary between what is known and what forever remains a mystery. He often said that nature's imagination is so much greater than man's, and nowhere was that more visible than in the strange perfection of QED. In laboratories around the world, physicists were now testing the theory he had built with playful brilliance. Every new experiment became a conversation with Feynman's diagrams. Beams of electrons and photons were made to collide inside accelerators, and the results matched the predictions of QED to astonishing precision. The agreement between theory and experiment was like a symphony played on two instruments, an entire universe apart, yet somehow in perfect tune. It was a triumph not only for physics but for the human mind's ability to describe the invisible. Feynman was delighted, but never complacent. He knew that each answer led to 100 new questions. How could something so bizarre, particles taking every possible path, existing in multiple states at once, lead to results that were so exact? How could a theory built on uncertainty be so precise? This paradox fascinated him. He felt that QED was not only about particles, but about the philosophy of knowledge itself. He often joked, "If you think you understand quantum mechanics, you don't." Yet, his laughter carried a deeper message. That understanding didn't mean removing mystery. but learning to live gracefully within it. In his lectures, he would draw his beloved diagrams on the blackboard, arrows and squiggles connecting points of interaction. Then he'd step back, look at the students and smile. "All of this," he'd say, "tells us how light and matter talk to each other. Every photon, every electron, is engaged in an endless conversation, exchanging energy, dancing through possibilities, and deciding what happens next. The universe is a dialogue." Those who listened realized they weren't merely studying physics, they were witnessing the poetry of existence. The reach of Feynman's ideas went far beyond the walls of physics departments. His diagrams became tools for exploring not just electromagnetism, but the deeper structure of all interactions: strong, weak, gravitational. The quantum field theories that later described the standard model of particle physics were, in essence, extensions of the logic born in QED. The physicists who worked on quarks and gluons, on the Higgs field and beyond, all carried a piece of Feynman's vision with them. The elegant arrows and wavy lines he invented became the visual grammar of the subatomic world. Feynman never sought ownership of these ideas. He loved seeing others expand upon them, reinterpret them, and discover new truths. "Physics," he'd say, "is like sex. Sure, it may give practical results, but that's not why we do it." It was his way of reminding everyone that curiosity, not utility, is the soul of science. To him, the joy was in figuring things out, in the thrill of turning confusion into clarity. And nowhere was that joy more visible than when he talked about QED. As the 1960s and 70s unfolded, the world around him changed. Computers began to rise, rockets reached for the moon, and humanity's ambitions grew cosmic. Yet, at the heart of every new technology was the same principle that Feynman had uncovered: the interaction of light and matter. Lasers, transistors, LEDs, quantum sensors, all were rooted in the understanding of how photons and electrons behave. QED was quietly powering the modern age, even as most people who used its fruits had no idea of the strange beauty beneath their everyday machines. Feynman often found humor in this irony. He loved to tell stories about people asking him what practical use his theories had. He'd grin and answer, "Nothing, except explaining everything." For him, the reward was not application, but insight. He cared less about how his equations could build a device, and more about how they revealed the rhythm of nature. When he looked at light reflecting off water, he didn't just see a shimmer, he saw a million photons interfering, canceling, reinforcing, performing the cosmic arithmetic his diagrams described. One of the most fascinating aspects of QED was how it reframed the very concept of causality. In the classical world, events follow one another like dominoes. In Feynman's quantum world, everything happens all at once, past, present, and future intertwined in a dance of probabilities. Particles could influence each other across space-time, and their histories could loop back upon themselves. To the uninitiated, this sounded like science fiction. To Feynman, it was simply how the universe worked. He showed that the rules we observe emerge from a deeper layer of possibilities, as if reality were choosing, moment by moment, which version of itself to become. As he refined these ideas, Feynman continued to teach with a passion that electrified everyone around him. His Feynman lectures on physics at Caltech became legendary, not only for their clarity but for their sense of adventure. In those lecture halls, quantum electrodynamics was not an abstract theory, it was a living story of exploration. He would sketch a photon scattering off an electron, pause, and say, "This is what really happens. These are the little arrows nature draws when she decides what light will do." His voice carried excitement, not solemnity, because for him, knowledge was a form of play. He never let formality get in the way of truth. When confronted with rigid traditions or overly complicated explanations, Feynman would shrug them off. He despised pretension in science. To him, if you couldn't explain it simply, you didn't really understand it. That belief shaped how generations of physicists would think. Many who once feared quantum theory began to approach it with curiosity instead of dread. guided by Feynman's humor and insight. He turned one of the most difficult subjects in science into something human, almost intuitive. In the broader scientific community, Feynman's QED became a foundation for everything that followed. When the electroic theory united electromagnetism with the weak nuclear force, its roots were unmistakably Feynmanian. When quantum chromodynamics explained the strong force binding quarks together, its diagrams were direct descendants of his. Even in cosmology and string theory, echoes of QED's structure persisted. It was as if the fingerprint of Feynman's imagination had spread across the entire canvas of modern physics. But behind his public brilliance was a deeply reflective man. After the death of his first wife, Arline, during his early career, Feynman had developed a profound respect for the fragility of life. To him, physics was not a cold intellectual pursuit, it was a way of staying connected to the beauty that remains after loss. The universe, in its endless complexity, became both a puzzle and a comfort. In his later years, when he spoke about QED, there was always a quiet reverence beneath the excitement, a sense that through understanding light, he had learned something about the nature of being itself. He once wrote that, "The imagination of nature is far greater than the imagination of man." QED had shown him that truth vividly. No matter how creative human minds could be, the universe always surpassed them, revealing patterns more intricate and surprising than any artist could invent. He took joy in that humility, in knowing that even after uncovering so much, mystery remained. To Feynman, that was the essence of science, to be endlessly curious, to never stop asking, and to find delight in not knowing. Even toward the end of his life, when illness began to slow him, his mind remained vibrant. In interviews, he would laugh about the absurdities of quantum mechanics, about how photons seem to make up their minds by trying everything at once. "It's crazy," he'd say, "but it works." He spoke with the same childlike wonder he had as a boy tinkering with radios. That continuity, the persistence of joy, was what made him extraordinary. For Feynman, the game never ended, it just kept getting more interesting. What made QED truly timeless was its blend of simplicity and depth. It was a theory you could sketch on a napkin, yet it held within it the precision to describe reality at the smallest scales ever measured. It told us why mirrors shine, why atoms emit colors, why the sky is blue. It linked the visible and invisible in one coherent narrative. That balance, between beauty and truth, imagination and rigor, was Feynman's signature. He believed that science should not only inform but also inspire, and QED was his greatest inspiration. When young scientists today trace lines on paper representing photon exchange, they are continuing his legacy. They may not all remember his jokes, his accent, or his bongo drums, but they speak his language every day. Each diagram drawn on a chalkboard is a silent tribute to the man who made the quantum world visible. In that sense, Richard Feynman never really left. His ideas live wherever curiosity meets courage. In his final lectures, he often reminded students that doubt was not weakness but strength. "I can live with doubt and uncertainty and not knowing." He said, "I think it's much more interesting to live not knowing than to have answers which might be wrong." That statement was not only his philosophy of life, but also the spirit of QED itself. The theory was built on uncertainty, on the acceptance that nature chooses through probability, and yet from that uncertainty arose the most accurate description of reality ever made. As the 1980s drew to a close and Feynman's health declined, he remained defiant, humorous, and endlessly curious. When doctors told him his cancer had returned, he shrugged and said, "I'd hate to die twice. It's so boring, even in facing death." He spoke with the same wit that had illuminated the darkest puzzles of physics. His final conversations were filled not with fear, but with fascination. About what lay beyond, about whether the laws he had studied all his life continued in some unimaginable form. When he passed away in 1988, the scientific community felt an emptiness that equations could not fill, but his legacy was already woven into the structure of science itself. Every successful prediction of QED, every shimmering experiment confirming its precision, was like an echo of his laughter. The theory had outlived its creator, and in doing so, it had immortalized him. Today, as physicists push beyond the standard model, as they search for unification and quantum gravity, they still carry Feynman's lesson, that the path to truth begins with wonder. QED remains a reminder that simplicity and playfulness can unlock the deepest secrets of the cosmos, and when light scatters from matter in precisely the way his equations predict, it is as though the universe itself is whispering his name. Richard Feynman did not just make quantum physics accessible, he made it human. He showed that science is not a fortress of logic, but a playground for imagination. His diagrams transformed incomprehensible infinities into stories that even a curious child could glimpse. His laughter turned fear of the unknown into fascination. And his quantum electrodynamics, that miraculous synthesis of light and matter, remains one of humanity's greatest intellectual triumphs. In the end, the theory and the man became inseparable. QED was Feynman's portrait of the universe, intricate, unpredictable, and endlessly alive. It was the music of creation written in the language of possibility, and as long as light continues to shine and matter continues to dance, the spirit of Richard Feynman will always be there, smiling, sketching, and reminding us that nature's greatest secret is joy. In the world of science, there are thinkers who discover truths, and then there are those rare souls who make those truths come alive for everyone else. Richard Feynman was one of those few, a physicist whose chalkboard became a theater, whose equations turned into stories, and whose words made the universe sound like a grand adventure. He was not content to understand the laws of nature. He wanted others to feel their beauty. His teaching was not just about transferring knowledge, but about awakening curiosity, that restless hunger to ask, why, until the very end of time. From the earliest days of his career, Feynman seemed destined to teach. Even as a young student at MIT and Princeton, he could take complex mathematical ideas and explain them in ways that made others laugh, gasp, and nod with understanding. His classmates used to say that when Feynman explained something, it felt as if the fog lifted and the landscape of truth appeared right before your eyes. He could take what looked like chaos on paper and reveal its hidden simplicity. He had the rare gift of turning confusion into wonder. When he joined the faculty at Caltech after the war, Feynman quickly became a legend, not just as a Nobel Prize-winning physicist, but as an extraordinary teacher. His lectures were not dry recitations of formulas, they were performances. Students would fill the halls long before he arrived, some sitting on the floor, others standing in the aisles, all waiting to see what he would do next. He would stride into the room with his sleeves rolled up, pick up a piece of chalk, and dive into the subject with contagious enthusiasm. His voice carried energy, fast, bright, alive. When he spoke, physics stopped being a collection of facts and became a living, breathing story about how the universe works. Feynman had no patience for rote memorization or rigid structure. He wanted his students to understand, to see beneath the surface of things. He often said, "What I cannot create, I do not understand." To him, learning meant reconstructing knowledge from the ground up, not accepting it on faith. If a student could not explain a concept in simple terms, Feynman would say, "You don't really know it." This became known as the Feynman Technique, a method for true understanding. Explain it simply, and if you can't, go back and learn it better. In his classroom, every concept became a story. When he described atoms, he spoke of them as little dancers moving in patterns too small to see. When he explained light, he spoke of it as a messenger carrying whispers between particles. He would draw diagrams, wave his arms, mimic waves, and joke with his audience. Anything to make the abstract tangible. To watch Feynman teach was to witness physics come alive. The blackboard became a portal into the microscopic and cosmic, and his laughter was the sound of discovery. He didn't believe in separating science from art or imagination. The highest forms of understanding, He once said, art, poetry, and science. They are all about seeing the world in a new way. For Feynman, physics was not just equations, it was beauty. He saw the patterns in nature as poetry written in numbers and shapes. He often compared the world to a grand piece of music. Complex, harmonious, and endlessly creative. He wanted his students to hear that music too, to find joy in its rhythm and mystery. One of the greatest legacies of his teaching came in the early 1960s, when Caltech asked Feynman to redesign the introductory physics course for undergraduates. He accepted, but in his own unpredictable style. Instead of repeating the standard lessons, he decided to teach physics from the beginning, as if the students, and he himself, were discovering it for the first time. For 2 years he poured his soul into this project, delivering what would later become the Feynman Lectures on Physics, a 3-volume masterpiece that remains one of the most beloved scientific texts ever written. These lectures were not ordinary notes, they were alive with his spirit. Every page reflected his passion for clarity, his humor, and his refusal to oversimplify the truth. He explained relativity, quantum mechanics, electromagnetism, and thermodynamics not as distant, mechanical laws, but as living ideas born from curiosity. Even decades later, students and teachers alike still turn to those lectures, hearing his voice between the lines, guiding them gently toward understanding. In a sense, Feynman is still teaching, every time someone opens those pages. But Feynman's genius as a teacher was not only in his explanations, it was in his attitude. He treated learning as an act of joy, not duty. He would say, physics is like sex. Sure, it may give practical results, but that's not why we do it. It was his way of reminding everyone that the true purpose of learning is delight. His students learned to see that curiosity itself was sacred, that the pleasure of figuring something out was one of life's greatest rewards. He never let fear or formality silence that curiosity. If a question sounded silly, he welcomed it. If an idea sounded impossible, he chased it anyway. What made him even more extraordinary was how he could reach beyond the walls of academia. Feynman could explain the subtlest ideas in quantum physics to people who had never studied science. He appeared on television, gave public talks, and wrote popular books like "Surely You're Joking, Mr. Feynman!" and "The Character of Physical Law." In these, he showed the world that science was not cold or mechanical, but deeply human, full of laughter, mistakes, and wonder. He told stories about his experiments, his adventures in Brazil, his bongo playing, and even his time cracking safes at Los Alamos during the Manhattan Project. Through it all, his message was the same: science is for everyone who is curious. He believed that good teaching was about awakening the imagination, not transferring information. "I would rather have questions that can't be answered," he said, "than answers that can't be questioned." That statement captured the essence of his philosophy. He wanted his students to be explorers, not followers. He encouraged them to doubt, to test, to break the boundaries of their understanding. For him, the goal of education was not to fill the mind, but to ignite it. Perhaps one of the most powerful stories about Feynman's teaching came from his time in Brazil in the 1950s, when he observed how science was being taught there. Students could recite formulas and definitions perfectly, yet they didn't actually understand what those formulas meant. They could answer any question from the textbook, but if you asked them to apply that knowledge to a real situation, they were lost. Feynman was appalled. He realized that education, if done wrong, could kill curiosity instead of nurturing it. He gave a speech there, urging teachers to stop training students to memorize and instead teach them to think. "You can know the name of a bird in all the languages of the world," he said, "but when you're done, you'll know absolutely nothing about the bird." What mattered was not names, but understanding. His approach to teaching inspired not only physicists, but educators across every discipline. He showed that the heart of good teaching is honesty. The courage to admit what you don't know, the patience to find out, and the passion to share what you discover. He was unafraid to say, "I don't know," because he understood that ignorance is the beginning of learning. His humility made his genius approachable. His humor made his brilliance lovable. In classrooms, he would often perform little demonstrations, spinning plates, playing with magnets, showing patterns in sand, all to reveal that physics wasn't something distant, it was happening everywhere, in every moment. To him, the universe was a playground. "I learned very early," he said, "the difference between knowing the name of something and knowing something." And he wanted everyone, from scientists to children, to experience that difference for themselves. Feynman's way of teaching wasn't limited to words. He used his entire personality as a teaching tool. His facial expressions, his energy, his quick jokes, even his storytelling rhythm, all were carefully tuned to keep curiosity alive. His classes were not lectures, they were conversations with the universe. The students were not just listeners, they were participants in the act of discovery. That's why so many who studied with him later said that even when they didn't fully understand the math, they understood the beauty. His legacy as a teacher reached its peak when he began to address not just how we teach physics, but why. He reminded the world that education should never lose its sense of wonder. He argued that science was not about certainty but about doubt, not about final answers but about endless questions. "The pleasure of finding things out," he said, "is the greatest gift of science." He taught that curiosity is the engine of progress and that humility is its compass. Even as his fame grew, Feynman remained grounded. He rejected honorary degrees, avoided pomp, and insisted on being called simply Dick. Students were often surprised at how approachable he was. He would sit with them in the cafeteria, listening, laughing, drawing diagrams on napkins. He treated everyone, from freshmen to senior scientists, with the same enthusiasm. For him, everyone was a potential explorer, no matter how much or little they knew. He didn't just teach physics. He taught how to think. He taught how to look at a problem from every angle, how to play with ideas until they revealed their secrets. He encouraged his students to trust their intuition, but always test it. "The first principle is that you must not fool yourself," he said, "and you are the easiest person to fool." That simple line became a moral compass for generations of scientists, a reminder that honesty with oneself is the foundation of all discovery. Feynman's influence went far beyond his own lifetime. Long after his death, his lectures continued to inspire millions. They became videos, audiobooks, and online courses that reached every corner of the globe. People who had never set foot in a university found themselves enchanted by the way he spoke. His laughter still echoes through classrooms and screens, carrying the same message: the universe is yours to explore. What made his teaching timeless was not only its brilliance but its humanity. He understood that science is not separate from life, it is life, the act of paying attention, of caring enough to ask why things are the way they are. He taught that the world's beauty doesn't fade when you understand it, it deepens. "You can appreciate a flower better if you understand how it works," he said. "The beauty isn't lost, it's multiplied." By the end of his career, Richard Feynman had become more than a physicist. He was a storyteller of reality, a bridge between the known and the unknown. His classrooms had become stages, his chalkboard a window into the infinite, and his laughter the heartbeat of discovery itself. To learn from him was not only to understand physics, it was to fall in love with the act of learning. As the sun of Richard Feynman's career rose higher, his journey as a teacher became not just a part of his profession, but the soul of his existence. His way of communicating science began to transcend the walls of Caltech and reach the hearts of ordinary people. Feynman had turned physics from a rigid, mathematical subject into a living art of exploration. His words carried emotion, his tone carried enthusiasm, and his curiosity carried the spark that ignited countless young minds. For him, science was not a temple of rigid rules, but a playground of ideas where imagination could dance freely. The classroom became his stage, and his lectures performances of wonder. Students did not merely attend his classes, they experienced them, as if they were traveling with him through the invisible architecture of nature itself. He had a way of making even the most complicated ideas feel like stories from life. When he spoke about electrons jumping between energy levels or light behaving like both waves and particles, he did not just describe equations. He told stories of how nature hides her secrets in layers of mystery and how human curiosity is the only key to unveiling them. His voice, filled with excitement and humor, created a rhythm that captivated listeners. They laughed, they thought, and they began to see physics as a journey, not a struggle. Feynman believed that teaching should never feel like memorizing, it should feel like discovering something new every time. In every classroom, he turned learning into an act of adventure. His lectures at Caltech became legendary, recorded and preserved as the Feynman Lectures on Physics. In these, Feynman did not write a traditional textbook. He built a bridge between complex science and human understanding. He wanted students to see beauty in equations, to feel the poetry in numbers, to sense that behind every law of physics lies a profound elegance. When he spoke about nature, his eyes lit up with the same wonder as a child staring at the stars for the first time. His teaching was not about showing what he knew, but about sharing the joy of knowing. Every concept he explained carried a heartbeat of excitement, a feeling that something extraordinary was waiting to be understood. What made Feynman different was not just his intelligence, but his empathy as a teacher. He understood what it meant to be confused. He often said that the only way to truly master a subject was to explain it so simply that even a child could understand it. His Feynman Technique became famous, a method of learning where one teaches by simplifying. He encouraged students to break every problem into smaller, understandable parts and rebuild the idea from scratch, without fear of being wrong. He taught that confusion is not a weakness, but the beginning of understanding. His humility made him accessible, and his humor made him unforgettable. He refused to be a distant intellectual. He wanted to connect, to talk, to laugh, to make people see that physics was not just a subject but a way of seeing the world. He used drums, stories, jokes, and even pranks to keep curiosity alive. Once, when asked how magnets attract each other, he replied by explaining not just the force, but the philosophy of asking why, showing that sometimes the beauty of science lies not in finding all the answers, but in asking the right questions. To Feynman, a question was not a problem, it was a doorway. And every student who entered that doorway found themselves in a universe full of possibilities. Feynman's unique teaching style began to inspire educators around the world. They saw in him the image of a teacher who did not separate intellect from emotion. He believed that knowledge without curiosity was empty. In every lecture, he tried to awaken the part of the human mind that wonders. He reminded people that curiosity was not something to grow out of, it was something to grow with. This philosophy made him not just a teacher of physics, but a teacher of life. Students often said that after listening to him, they did not just understand physics better. They began to see the world differently. They saw patterns in chaos, harmony in equations, and meaning in the very fabric of the universe. He never believed in formality. He preferred the language of imagination over jargon. When others complicated ideas, he simplified them with creativity. To explain atoms, he spoke of tiny spinning balls. To describe light, he used arrows dancing in different directions. His chalkboard became a canvas of thoughts, filled not with confusion, but with clarity. The elegance of his drawings, the rhythm of his speech, and the sparkle in his eyes made even the hardest subjects feel alive. Students left his lectures with more than knowledge. They left with curiosity rekindled, a hunger to explore the unknown. Beyond classrooms, Feynman's influence reached the world through his public talks and writings.
Books like "Surely You're Joking, Mr. Feynman!"
And "What Do You Care What Other People Think?" revealed the playful and deeply human side of science. He told stories of his adventures, breaking safes at Los Alamos, learning to play bongos in Brazil, deciphering Mayan hieroglyphs, and exploring art and biology, to show that science was not a separate world, it was connected to everything. His stories made people laugh, but beneath that laughter lay a powerful message that curiosity and joy are the true fuels of discovery. He showed that science was not cold logic but a celebration of being alive in a mysterious universe. In every word he spoke, there was an invisible melody of passion, a rhythm that resonated with listeners. Feynman never tried to make himself look superior, he made people feel capable. He wanted everyone, whether scientists or students, to believe that understanding nature was within reach. His words were like light entering a dark room, illuminating corners of thought that many had ignored. His laughter, infectious and spontaneous, became the sound of learning without fear. He tore down the invisible wall between genius and ordinary minds, showing that curiosity belongs to everyone. As years passed, his style of teaching began to be seen as revolutionary. In an era when education was often rigid, Feynman made it personal. He did not just transmit information, he transferred excitement. He taught people not what to think, but how to think. He believed that real learning happens when one questions deeply, when one observes rather than memorizes. This was the core of his philosophy, that understanding grows from wonder. His legacy as a teacher became greater than his scientific fame, because he taught generations to never lose their sense of play. Even after his death in 1988, his words continued to echo. His recorded lectures still inspire millions online decades later, proving that his style of teaching was timeless. Each time a student listens to his explanations, it feels as if he is speaking directly to them, with warmth, humor, and honesty. His laughter still travels through time, reminding us that learning can be joyful, that curiosity is sacred, and that the universe is not a puzzle to be solved, but a story to be lived. Richard Feynman transformed teaching into an act of love, love for nature, for discovery, for the thrill of not knowing. His gift to humanity was not just his intellect, but his ability to make others believe in their own. He made physics not a distant mountain, but a road anyone could walk, guided by curiosity and courage. Through his words, we learn that knowledge is not power, it is play. It is the joy of understanding a little more of the grand design that surrounds us. And in that realization, Richard Feynman remains immortal, not as a man who knew everything, but as the teacher who showed us how to fall in love with learning itself. During the dark and uncertain years of World War II, Richard Feynman found himself standing at the crossroads of science and history. Still a young physicist, full of energy and restlessness, he was drawn into one of the most secretive and consequential scientific projects in human history, the Manhattan Project. It was a time when the world was divided by fear and ambition, and scientists were being called to use their intellect for war. Feynman, driven by curiosity and a sense of duty, joined the effort to unlock the power hidden within the atom, not yet knowing how profoundly it would shape both his career and his conscience. At Los Alamos, the secret city in the desert of New Mexico, Feynman's brilliance quickly became evident. Surrounded by the greatest scientific minds of the time, Oppenheimer, Teller, Bethe, and others, he worked tirelessly on the theoretical calculations needed for the atomic bomb. But even amidst this atmosphere of high security and tension, his playful curiosity remained alive. Feynman was fascinated not only by the physics, but by the intricate systems of secrecy that governed the project. He became notorious for picking locks, opening safes, and slipping past security barriers, not out of rebellion, but out of an unstoppable desire to understand how things worked. He treated even the most serious environment as a puzzle to be solved, a reflection of his unbreakable curiosity. The war pushed science into an ethical gray zone. Feynman and his colleagues were building something that could change the world forever, for better or worse. When the first atomic bomb was tested in July 1945, Feynman watched the explosion from a safe distance, his eyes shielded by glass. In that blinding flash, he saw both the triumph of human intellect and the shadow of destruction it could bring. The moment filled him with awe but also unease. It marked a turning point in his life. The realization that knowledge could no longer be separated from responsibility. Science had given humanity power, but it had also given it a choice about how to use it. After the war, Feynman carried with him a deep awareness of this moral weight. He had lost his young wife, Arline, during the war, and her death, combined with the devastation caused by the bomb, changed him. He began to see life with a new humility and a new focus on meaning. He decided that his future would not be about weapons or power, but about understanding and teaching. The war had taught him how dangerous blind obedience and secrecy could be, and how vital open inquiry and honesty were to the spirit of science. He often reflected that while the Manhattan Project had been a monumental achievement, it also served as a warning about the double-edged nature of human ingenuity. In later years, Feynman rarely spoke with pride about his role in the bomb's creation. Instead, he used it as a lesson in the ethics of science, reminding young scientists that knowledge must serve humanity, not harm it. He believed that curiosity should never lose its moral compass. The experience at Los Alamos had shown him the brilliance and the fragility of the human mind, how it could create both beauty and destruction. It was this balance, this awareness of light and shadow, that shaped the depth of his later teaching. Through the chaos of war, Feynman emerged not as a soldier of science, but as a philosopher of it. He had seen the heights of achievement and the depths of consequence. The Manhattan Project had forged in him a new purpose: to dedicate his life to curiosity guided by conscience, to discovery guided by responsibility. And in that transformation, Richard Feynman became more than a physicist. He became a voice reminding the world that the pursuit of knowledge must always walk hand in hand with wisdom. In the vast landscape of modern physics, few creations have shaped scientific understanding as deeply as Richard Feynman's diagrams. These simple yet profound sketches transformed how scientists visualize the invisible world of subatomic particles. Before Feynman, the equations of quantum electrodynamics were like a tangled forest of mathematical expressions, beautiful but nearly impenetrable. Physicists struggled to navigate the interactions between particles, light, and energy. Then came Feynman, with his childlike imagination and gift for clarity, who found a way to make the abstract visible. Out of lines and arrows drawn on paper, he gave form to the unseen, the dance of particles that make up the universe itself. The birth of the Feynman diagram began as an act of simplification. While working to explain how particles like electrons and photons interact, Feynman realized that words and formulas were not enough. He began sketching lines representing particles and their exchanges, creating a visual map of events that happen in the blink of a quantum instant. Each line told a story: an electron traveling through space, a photon emitted or absorbed, a transformation taking place beyond the limits of sight. What had once been equations filled with complexity now became pictures that anyone trained in physics could read. It was as if he had invented a new language, one that allowed scientists to see quantum reality with their eyes instead of only imagining it through numbers. The diagrams quickly became more than a tool, they became a revolution. They allowed physicists to calculate probabilities of interactions with unprecedented precision. Through them, the abstract world of quantum mechanics gained a structure that felt almost intuitive. The diagrams turned chaos into order, uncertainty into understanding. Feynman's innovation gave birth to a new generation of theoretical physics, one that could predict the behavior of the smallest elements of matter with astonishing accuracy. His work on quantum electrodynamics eventually earned him the Nobel Prize, but the real prize was something greater. He had given science a visual grammar for the invisible universe. Feynman's diagrams were not just scientific instruments, they were symbols of his philosophy. They reflected his belief that simplicity was the heart of truth. He often said that nature's beauty lies in her simplicity, that behind all the complexities of the universe, there must be patterns that can be grasped by the human mind. The diagrams embodied that belief. They were playful yet powerful, simple yet profound, mirroring the very personality of the man who created them. In a sense, Feynman had drawn not only the pathways of particles, but also the pathways of human understanding. What made these diagrams even more remarkable was their universality. They transcended language, nationality, and culture. Physicists across the world could communicate complex interactions just by drawing a few lines and arrows. It was like a musical notation for science, where every symbol carried a rhythm of meaning. Decades later, they remain the foundation of how quantum field theory is taught and understood. Every modern physicist who studies particle interactions walks in the footsteps of those lines that Feynman once drew on a chalkboard with a spark of excitement in his eyes. But beyond their technical value, the Feynman diagrams captured something deeply human: the desire to make sense of the unseen. They represented the fusion of imagination and intellect, of art and science. Feynman's hand-drawn arrows were not just scientific tools, they were strokes of creativity, reminders that discovery is born not from memorizing equations, but from daring to imagine. He once said that he could see the dance of electrons in his mind. Through his diagrams, he invited the world to see it too. In the end, the Feynman diagram became more than a scientific legacy. It became a symbol of how genius and simplicity can coexist. It stood as proof that even the most complex mysteries of the universe could be translated into human understanding with enough curiosity, clarity, and creativity. Richard Feynman had turned the invisible into the visible, the incomprehensible into the elegant. His diagrams continue to whisper across generations of scientists, reminding them that the universe, in all its mystery, can sometimes be explained with nothing more than a few lines, a few arrows, and the boundless curiosity of a mind that never stopped asking why. Richard Feynman's voice carried something rare, a fusion of laughter, intellect, and awe. When he spoke, it was not merely to explain physics, it was to make his audience feel the wonder of the universe. His style of communication was as unique as his mind. He didn't just talk about quantum mechanics. He painted it with words, using humor and stories to bring the invisible world of particles to life. His tone was alive with energy, like the spark of an electron jumping between states. When Feynman explained an idea, you could sense that he wasn't lecturing, he was sharing joy. His joy came from discovery, from peeling back the layers of reality and showing others that learning could be an act of celebration rather than struggle. He never believed in formality or intellectual distance. To him, science was too beautiful to be hidden behind jargon. He spoke with the same passion to students, scientists, or a child on the street. He loved simplicity, not because it was easy, but because it was honest. His laughter filled lecture halls, his metaphors made people smile and think at the same time. Feynman could describe atoms as tiny dancers in an endless rhythm, or light as nature's conversation with itself. This poetic clarity made him unforgettable. People who attended his talks often said it felt less like a class and more like being inside a story where the main character was nature itself. Feynman's genius as a communicator came from his deep empathy. He understood confusion, and he respected it. He knew what it meant to not understand something, and he used that as his starting point. Instead of intimidating his listeners with knowledge, he invited them to explore alongside him. He turned science into a shared adventure, filled with mistakes, laughter, and moments of sudden clarity. If you can't explain it simply, he said, you don't understand it well enough. This philosophy guided his every word. For Feynman, the goal was not to impress, but to illuminate, to shine a light on the path of curiosity so that others could walk it too. Even when he was explaining the most complex concepts, like the behavior of photons or the uncertainty principle, he spoke with a rhythm that made listeners lean forward in fascination. He often told stories from his own experiences, mixing humor with deep insight. He described the universe not as a collection of facts, but as a grand mystery waiting to be touched. In his hands, physics became a form of art, a language of beauty and truth. His lectures at Caltech became famous around the world for this very reason. They were not performances of ego, but of curiosity. He treated every question with respect, every idea with wonder, and every listener as a partner in discovery. Feynman's communication style was not confined to classrooms. He became a global voice for science through his books, interviews, and public appearances. His stories of learning to play the bongos, studying biology, or cracking safes at Los Alamos were not distractions, they were lessons. Each one revealed his belief that curiosity should never be limited to one field. To him, curiosity was universal, it was the pulse of creativity. Whether he was talking about quantum theory or playing music, he spoke the same language, the language of enthusiasm. He showed that science was not separate from life, but woven into every heartbeat, every color, every sound. When he spoke to non-scientific audiences, he didn't simplify the science, he made it relatable. He compared atoms to people, particles to stories, and experiments to adventures. He wanted everyone to feel that they, too, could understand the secrets of nature. His passion made physics human. It made people believe that the universe was not cold and distant, but alive and full of meaning. Feynman's laughter, often spontaneous and loud, became the sound of curiosity itself, a reminder that learning should never lose its joy. In an age when science was often seen as dry or inaccessible, Feynman brought warmth and humanity to it. He reminded people that the essence of discovery was not in facts, but in wonder. Through his words, millions who had once feared physics began to love it. His communication style turned him into a global teacher. Not through authority, but through authenticity. He never pretended to have all the answers. Instead, he celebrated the beauty of not knowing. He often said that uncertainty was not something to fear, but something to explore. This honesty made him deeply trusted, not only as a scientist but as a thinker of life. Even decades after his death, his voice continues to echo in recordings, books, and memories. When people hear him explain the motion of planets or the behavior of light, they don't just learn physics, they learn how to see. His communication was not about transferring information, but about transforming perception. He taught that science is not the opposite of emotion, but its companion, that understanding the universe can move the heart as deeply as art or music. Richard Feynman's style of communication remains one of the greatest gifts he left to the world. He proved that science could be spoken with humor, humanity, and heart. He turned equations into stories, formulas into poetry, and theories into conversations. Through his laughter, his metaphors, and his boundless enthusiasm, he made quantum physics not only understandable but alive. And in doing so, he gave the world something timeless: the belief that curiosity, when shared with passion, can connect every human being to the infinite mystery of the cosmos. As the years passed and Richard Feynman's hair turned silver, his legacy grew far beyond the realm of equations and experiments. He had already won the Nobel Prize, revolutionized quantum theory, and transformed science education. Yet, what made him truly immortal was not just what he discovered, but how he has inspired. He became the symbol of a new kind of scientist, one who embraced curiosity, joy, and humility all at once. Feynman's legacy was not written only in papers or lectures, it lived in the hearts of those who learned from him, directly or through his words. He was the teacher who made quantum physics human, who made the act of learning feel like a conversation with the universe. Feynman often said that the pleasure of finding things out was life's greatest reward. That simple phrase became the essence of his philosophy. For him, knowledge was not about prestige or fame, it was about wonder. He believed that curiosity was the engine of progress, that every question, no matter how small, could open a door to something magnificent. In a world often driven by ambition and competition, Feynman stood out as a man who learned for the sheer joy of it. He showed that the greatest scientists are not those who know everything, but those who never stop asking why. Even after his passing in 1988, Feynman's ideas continued to ripple through time. His Feynman lectures on physics became sacred texts for students around the world, timeless in their clarity and insight. Through them, countless people encountered physics not as a cold discipline, but as a living story, full of color, motion, and meaning. His writings,
Like, surely you're joking, Mr. Feynman?
revealed the mischievous and deeply human side of a scientific genius. In those pages, readers met a man who laughed, who made mistakes, who danced with curiosity in every direction. His legacy was not about perfection, it was about passion. He left behind not only theories but a spirit, a way of seeing the world. Feynman's legacy taught that science and life are not separate pursuits. He showed that curiosity about nature is the same force that drives art, music, and love. The scientist and the artist, in his view, were both seekers of beauty, one through equations, the other through expression. He often said that understanding a flower through science does not destroy its beauty, it reveals even more layers of it. That thought captured who he was, a man who found poetry in precision and magic in logic. Feynman's influence also extended into culture and philosophy. He reminded the world that honesty was the foundation of science, that it is better to admit ignorance than to pretend certainty. He despised arrogance in academia and believed that real wisdom begins with humility. The first principle is that you must not fool yourself, he said, and you are the easiest person to fool. This line became one of his greatest lessons, a truth that applies far beyond physics. It was a call for integrity, for courage in the face of uncertainty, for the humility to keep learning. Through his example, Feynman taught that teaching itself is a form of immortality. Every student he inspired became a carrier of his light. Every teacher who followed his example, explaining with joy, questioning with honesty, exploring with courage, became part of his living legacy. His name came to represent more than science, it represented curiosity itself. The laughter in his lectures, the excitement in his voice, the spark in his eyes, these became symbols of what education could be when fueled by passion rather than formality. Today, his legacy breathes in classrooms, in YouTube lectures, in documentaries, and in the countless minds that dare to explore without fear. His words still echo whenever someone finds beauty in an equation or marvels at the structure of an atom. Feynman showed that science is not a mountain to be conquered, but a playground to be explored. His joy in discovery became a universal language that continues to inspire young scientists, artists, thinkers, and dreamers. In the end, Richard Feynman left the world something far greater than scientific theories. He left a way of thinking, a way of feeling about life. He reminded us that the universe is not something to be solved like a puzzle, but something to be experienced with curiosity and awe. He taught that knowledge and wonder can live side by side, that laughter and learning belong together, and that the true purpose of science is to keep the spirit of exploration alive. His legacy lives not in the textbooks of physics, but in the hearts of those who, inspired by his spirit, continue to look up at the stars and whisper, "What else is out there to discover?"